Section 2.8 Exponential growth and decay is very relevant to our everyday life. For example, everyone will have a bank account, and depends on the bank account that you have, some saving account will give you a good interest rate, and we need to understand how interest is calculated so that we know what investment that we want to do to secure our financial future. So let's take a look at this problem. A bank pay a rate of 8%, which is not really happening nowadays, but it used to pay 5%. I still remember that back in the good old days. To get an interest rate of 8% is not impossible, but you have to invest in that case. But let's assume the bank pays interest rate of 8%. What is the yearly multiplier if the interest is compound yearly? Okay, so we need to understand what are they asking about the yearly multiplier, or what is compounded yearly. It compound yearly means it pay you interest once a year. And if it compounds 3 times a year, that means it pay you interest every 4 months. So at 4 months, it pay you a little bit, and then after they pay you, you have a little bit more money. So then they, based on that amount of money, add more interest the next time they pay you, and so on. So the formula for future value is 1 plus the interest rate divided by how many times it's paying you over the year, and then you raise it to the number of times it pay you times the number of years that it gives you. Okay, so R is the interest rate, and it's the number of times the interest is compounded, and T is the time in year. Okay, so that's the most and then you multiply by the present value, and you can refer back to the textbook. It gave you that formula, but not like the exact formula, just give you some numerical, and you need to figure out this formula. So here we have 8%, so we know the interest rate. So for A, we know the interest rate is 0.08. You always convert it to a decimal. And the number of times it compounds, because it says yearly, n equals 1, and it asks you the yearly multiplier. So we're saying, okay, each year, okay, 1 year, what do you get? So in that case, the multiplier is this piece, because you use that to multiply multiply what you have. So now we calculate a multiplier. It's just 1 plus 0.08 divided by 1 raised to the 1 times 1 power. Okay, enter that to your calculator, you get 1.08. And that is obvious, because if I pay you 8% interest and it compounds yearly, then it's just 1 plus 8%, which is 1.08. So then, but when we have a formula, it doesn't matter the situation. You always be able to figure it out. What if I say monthly? What if I say daily? So then it always just go back to the formula. So R equal 0.08, and this time is compound 3 times a year, and we're still talking about after 1 year, what do we have? So you plug it into the formula, 1 plus 0.08 divided by 3 times a year. And how many times it will compound? 3 times 1. Okay, so then you use a calculator, you should get 1.08215. So that is a multiply. You use that number to multiply by what you have, then you get your future value for the money. Now, for the last part, it's talking about how about continuously. Continuous interest. So in that case, we are saying n is approaching infinity because you keep compounding continuously. So what happened to our formula? We cannot just plug in infinity into the formula, right? So the textbook, checkpoint 2.42, okay? You follow checkpoint 2.42 in the textbook. It explains to you, okay, what is the limit. So in this case, we need to take the limit as n goes to infinity to find that, to find out the base or the multiplier. So what's happening is we're taking the limit as n goes to infinity. 1 plus 1 over n raised to the n power. Now this is given, this limit is given to you as e. Okay, we use this piece of information to realize, okay, our formula for future value or balance in the textbook it call you equals, and that limit is when n goes to infinity is e, and then it raised to the r times t power. Then you multiply by the present value. So this will be our multiplier. And how come it's e to the r times t power? We need to do some transformation in the limit. Okay, so now, but that is given to you in the checkpoint, so we can just use that for our problem. If you're interested in how to transform that limit and get that answer, you will need to let me know. So now, go back to our problem. What if the interest is compound continuously? Then we just plug it in, right? E raised to the 0.08. Okay, what is our t? As we say after 1 year, right? So then you just use a calculator. It's approximately 1.08329. So that will be the multiplier for 1 year. Now, that's another thing. So then we can raise a question. What if I put it in for 10 years? Does it mean that, oh, I get infinite amount of money? Well, not necessary, right? You can try it. You raise it to a big number, right? Nothing more than 200 years. You realize you still get a limited amount of money even though the interest is compound continuously.